Hey everyone, welcome to the What If live stream. It's great to have you all here. Mom, I see you joined us today. Look, I got about an hour's worth of the best what if scenarios of the year to show you, and I'm eager to get started, but I just want to let you know what's in store. Now, this was a great year for What If. We covered lots of new ground, did some longer form videos with me called What If Originals. We're upping our game with visual effects in our videos. We launched our Patreon. We introduced Chase, a new virtual character who will appear in some of our episodes. Look for him later in the show, but also watch for him in his own spin-off show coming soon. Also coming up at the show, you'll find out what evidence we might have about a Type 2 civilization, what Earth was like in the age of giant dinosaurs, and discover things that you were lied to about regarding space. But first, let me show you an example of our elevated visual effects that we're so proud of. In our first video today, what if you spent 5 seconds on Venus? Everything in the video except my voice is computer generated. Let me know what you think. Welcome to hell. Yep, sorry, I meant Venus. Welcome to Venus. Some say it's Earth's twin, but this world is nothing like home. And you're about to experience this scorching hot landscape firsthand. Your mission is to spend 5 seconds on this hellish planet. And trust me, these are going to be a very long 5 seconds. Venus is the second planet from the Sun and our nearest neighbor. At its closest approach, Venus is a mere 40 million kilometers away from us. After just 4 months in space, you'd finally be able to witness this beautiful but deadly planet up close. 4.5 billion years ago, Venus and Earth formed in the same corner of our solar system. This space rock is about the same size as Earth, and its gravity is similar too, but unlike our home, the surface situation on Venus is extreme. We know this because we've sent probes to this scorching world. Some probes orbited it, some made a flyby, and some even landed on the surface of Venus, but those didn't last very long. What happened to them? Well, that's what you're about to find out. Time to make your way down to the surface. Ah, don't these clouds look beautiful? Well, don't inhale them. These yellowish bands streaking across the sky are clouds of sulfuric acid. If you could only get a whiff of them, you'd smell the reek of rotten eggs. But to do that, you'd need to remove your helmet, and I definitely do not recommend that. At a height of 50 kilometers above the surface, visibility is poor. You'd hardly be able to see anything. The incredibly thick atmosphere would block views of this planet and its tens of thousands of volcanoes. The atmosphere is mostly made up of carbon dioxide, and because it's so thick, it traps heat on the planet's surface, keeping it nice and toasty. Just how toasty are we talking? You're gonna find out the hard way. As you descend another 15 kilometers, the haze would begin to clear. The world below would finally reveal itself. A rust-colored surface covered in mountains and volcanoes. Looks like this volcano is still active. You'd fly around a little to collect some samples and take in the view. Yep, the atmosphere is mostly carbon dioxide with traces of nitrogen. That checks out. Okay, well, let's see if you can land here. This looks like the spot.
Mission Control, am I clear for landing? Mission Control? Looks like there's no signal. Initiating the landing sequence without clearance. Fingers crossed.
Landing your spacecraft would kick up clouds of dust that would take several minutes to settle down in the soupy atmosphere. As it clears, you'd look up into the sky, but you wouldn't find the familiar yellow circle of the sun. On Venus, it always looks like dawn, no matter what time of day it is. That's because the Venusian atmosphere only lets about 10% of the sunlight that hits it reach the surface. But wait, what were we saying earlier about the space probe that landed on Venus? Oh yeah, Venera 13. This Soviet probe made its fatal landing back in 1981. It survived the descent and lasted for a whopping 127 minutes. That's longer than any other spacecraft that had made it to the surface. But then, Venera 13 gave way to the violent, uninviting environment of this hell. It was likely crushed under extreme pressure. Or it melted. But it's too late to turn around now. You've lived through the 1-hour-long landing, and you're so close. All you need to do to complete your mission is to spend 5 seconds out there. Yeah, out there. In the most extreme environment you've ever been to. You made it! Whoa, the atmosphere is so strange. You can hardly lift your arms. Even though Venus has about the same gravity as Earth, you'd be feeling the sheer weight of its immensely dense air. It would feel like you were walking through water. Very hot water. And you'd be glad you were wearing so much protective gear. A quick look at your thermometer would tell you that it's a sweltering 475 degrees Celsius out here. That's hot enough to melt lead. Your pressurized suit would be working hard to keep you safe. Without it, you'd be crushed under all that pressure before you could even complete your mission. This isn't so bad after all. Hey, if a spacecraft could last over 2 hours some 40 years ago, well, you and your shiny new gear can survive longer, right? Venus is right here for you to discover. Just take a few more steps. Suddenly, something distracts you from the first-hand human analysis of Venus's surface conditions. Your protective suit breaks. The drastic pressure shift would immediately make you feel like you were deep underwater. With an atmospheric pressure 90 times that of Earth, Venus would be crushing you from all directions. At the same time, you'd be struggling to breathe in an atmosphere without any oxygen. Any atmosphere you did manage to inhale would scald the inside of your mouth and the top of your throat. Unless you could scramble very quickly back to the safety of your spacecraft, you'd be dead within seconds. Hey, it could be worse. High above you, sulfuric acid clouds would be raining acid. But in this unbearably hot environment, the toxic rain wouldn't reach the surface. It would evaporate long before that. So at least you wouldn't have to worry about acid dissolving your skin and bones. That would be kind of gruesome. You know, in hindsight, maybe we shouldn't have sent you down to explore this hellish surface. Of all the planets in the universe, Earth is clearly the best for life, right? Wrong. Earth may be great, but scientists have discovered a few worlds that could be even better for life. Behold, KOI 5715.01. Most of the contenders on our super habitable planet list aren't the ones you could visit anytime soon. They are very far away. The top spot is held by one 3,000 light-years away from our solar system. KOI 575.01 would appear to satisfy the most basic requirement for supporting life. It exists in the Goldilocks zone of its star. So conditions wouldn't be too hot or too cold for a key life-supporting ingredient to exist on its surface: liquid water. But it would also check off many boxes to be considered super habitable. The planetary system it belongs to could be 5.5 billion years old, which would make it around 1 billion years older than our own solar system. And the planet would almost fit the size requirement. When looking for super habitable worlds, scientists keep their eyes peeled for planets that have a mass up to 1.5 times of our planet. And they should be about 10% larger, too. This size difference would help the planet retain heat. And if its average temperature was about 5 degrees Celsius higher than Earth's, well, this planet could have even richer biodiversity. Now, being almost double the size of Earth, KOI 5715.01 might overshoot this condition a bit. Besides, studies indicate that this planet is actually colder than Earth. But there's still hope. With the right atmospheric composition, a strong greenhouse effect could raise temperatures to the desired level. And as far as super habitable worlds go, well, we're just getting started. Approximately 2,700 light-years away is Kepler 69c. This super-Earth could be around 7 billion years old. This puts it perfectly in the estimated 5 to 8 billion year old age range for superhabitable planets. This range is based on the 3.5 billion years it took for complex life to appear on Earth. So the best chance for finding life could be on a planet a little older than us. Only this exoplanet could be a little too big to be superhabitable. It has a mass almost 4 times that of Earth. A rocky planet this big could have a single colossal continent that would have huge deserts in its center. But the coastline, washed by Kepler's ocean, could be your perfect spot to move to. Our next super-Earth shares a similar name, Kepler 1126b, except it would be located ever so slightly closer to home. Yeah, this planet is about 2,073 light-years away, and it belongs to a system that is 7.5 billion years old. It also orbits a yellow dwarf star, much like our own. Only Kepler 1126b is 2.5 times closer to its star than Earth is to the Sun. But that's no big deal because the star Kepler 1126b orbits is cooler than ours, so the habitable zone would exist in a range much closer in proximity to it. If you aren't feeling this nearness to a scorching hot star, there's another super-Earth on our list. And it's at a reasonable distance from home. Speculos 2c is located only 106 light-years away. Not that its proximity gives it any kind of advantage. It would still take you well over 200,000 years to travel to this super-Earth. And that's if you moved at the speed of NASA's Parker Solar Probe, the fastest probe ever launched. Speculos 2c does look promising, though. It's about 40% larger than Earth. There's also the potential for it being a rocky planet, just like ours. Now, despite the fact that it also exists in a habitable zone, its red dwarf star is still very small. It's only about 15% the size of our Sun. So this planet orbits around its star at a very close distance. And this close distance could mean that Speculos 2c is tidally locked to its star. This super-Earth takes 8.5 days to make one full rotation on its axis, as well as one orbit around its star. That would leave one side of the planet in constant daylight and the other in endless night. This means that life could be possible in the Terminator Zone, the thin strip of land between the two sides. We just need to get a better look to find out for sure. Okay, my choice there would be the Speculoos planet. Now, if you know anything about Speculoos, you'll know that the planet was named after these cinnamon ginger nutmeg cookies from Belgium. I call them windmill cookies. They're delicious. Now, how much time did you spend in history class? Well, the average high school history course has you in the classroom for about 120 hours each year. For some people, that's an eternity. Not me, I loved it, but what if I told you I could give you the history of the Earth in 10 minutes? Yeah, 4.5 billion years of history in the time it takes to boil a cup of tea. Watch this. In the past few billion years, Earth has been pummeled by asteroids, crashed into other planets, and frozen over several times. Not to mention being ruled by all kinds of crazy life forms. Sometimes it's a wonder that our blue homeworld has survived it all. But if we want to take a whirlwind tour of our planet's history, we'll have to start way back at the very beginning. Some 4.5 billion years ago, our solar system began to emerge out of a dense cloud of interstellar gas and dust. This cloud collapsed into a swirling disk of matter that got hotter and hotter and hotter until hydrogen fused into helium. And just like that, our sun was born. And baby Earth was on its way too. After the birth of our star, all the matter on the farthest ends of the spinning disk began to clump together. These clumps would be the seedlings for the planets and moons in our solar system. As they accumulated more matter, they grew bigger and more spherical. The clumps in the cooler regions of the solar system were mostly made of ice, liquids, and gases. Closer to the sun, all the rocky material formed the inner planets like Mars and Earth. This young Earth was incredibly active, volcanically speaking. It spewed out gases like hydrogen sulfide, methane, and carbon dioxide. These gases made up the very first atmosphere on our planet. Early Earth was constantly bombarded by large asteroids and comets, and soon Earth experienced an even more violent collision. Theia, a planet the size of Mars, slammed right into our young world. This epic collision threw chunks of matter all around Earth's orbit, and then gravity bound them together into what we know now as the Moon. On this hot, early Earth, there were no oceans. All water existed as gas. But 3.8 billion years ago, our planet cooled enough for water to condensate and become liquid. The very first primitive ocean covered this young Earth and turned it into a water world. H2O is an essential ingredient for creating living things, so with all that water, life appeared on Earth about 3.7 billion years ago. These earliest forms of life were microscopic organisms, but it was nearly 1 billion years after that that some of these organisms changed the course of the world. Earth didn't stay as a water world very long. Soon, the very first continents emerged from the ancient ocean. Scientists call them cratons. As more and more land rose from the ocean, the very first supercontinent appeared on the planet. Valbara wasn't exactly a supercontinent, it was pretty small. Scientists think it was smaller than the continent of Australia. Around 2.4 billion years ago, cyanobacteria evolved to become our planet's first photosynthesizers. Finally, we had some oxygen producers to make Earth's atmosphere much more hospitable. And the rest is history, folks. Just kidding, we've still got a long way to go. With all this new oxygen, Earth's atmosphere had much lower levels of carbon dioxide. And that made the planet icy cold. Much of our young world froze over as Earth saw its first ice age. Now, as Earth's atmosphere was changing, the continents were moving too. They broke up and reassembled into the next supercontinent, Rodinia. Rodinia was a real supercontinent. It may have been the largest supercontinent to ever cover the planet. And life? Well, life finally became more complex. But then something happened. Rodinia broke apart and a new supercontinent assembled. This one was called Pannotia. Then, between about 540 and 485 million years ago, there was an explosion of new life. This time was called the Cambrian explosion, and the animals that evolved during this period had hard body parts, like shells or spines. The most famous of all were the alien-looking trilobites. Around 440 million years ago, the climate suddenly shifted and the temperature of the ocean changed dramatically. Earth saw its first mass extinction event. This was the Ordovician Silurian extinction, and a majority of the life that had been spreading around the planet vanished. Many of these life forms laid the foundation for the ecosystems that we have on Earth today. Somewhere between 420 to 350 million years ago, the first trees arose from Earth's soil. And the first animals made their way to land, too. 250 million years ago, the planet was covered by our last vast supercontinent, Pangaea. Sadly, it was also during this period that Earth witnessed the greatest mass extinction event in our history, the Great Dying. Huge amounts of greenhouse gases and accelerated global warming wiped out about 90% of all species on Earth. But this mass extinction helped pave the way for the next wave of animals to evolve. 240 to 230 million years ago, the first dinosaurs appeared. For the next 150 million years, they'd rule the land. If you were there, you'd have witnessed the gigantic sauropod Argentinosaurus, the largest land animal ever. Or you might have been chased by one of the Earth's greatest apex predators, the T-Rex. And you'd also witnessed Pangaea breaking up and forming the continents we know today. Okay, you may already know where this is headed. 66 million years ago, an asteroid slammed into our planet, right where Mexico sits now. And it coughed up so much debris into the atmosphere that it blocked out the sun. This led to devastating climate changes that caused the dinosaurs to die out. In the next wave of emerging animals, mammals became more common. Around 6 million years ago, the earliest known humans started walking this world. This species was called Sahelanthropus, though they still likely walked on all fours. 4 million years ago, early humans began to walk upright, and about 1 million years later, they developed the first known tools, which they used to break things. Some 800,000 years ago, things sparked. These early humans discovered how to control fire and could now cook food and provide themselves with heat. Their brains continued to evolve, now more rapidly than ever. These humans learned to interact with each other and the surrounding world in whole new ways. Then, between 40,000 to 15,000 years ago, all other human species besides Homo sapiens went extinct. 10,000 years ago, Earth saw its earliest farmers. These previously nomadic humans stopped wandering the planet and finally put down their roots. Jumping way forward to about 250 years ago, the Industrial Revolution took place. We went through major technological, socioeconomic, and cultural transformations. Rural-based farm societies became more industrialized urban ones. Our human population continued to grow. By 1804, we reached 1 billion. By 1927, we'd hit 2 billion. And since the 1960s, the global population has risen faster and faster to where it is now, at over 8 billion people. And now there's a new threat to human existence and many other forms of life here on Earth: climate change. Temperatures and sea levels are rising worldwide, and biodiversity is declining. We could be on the verge of another mass extinction event if things don't change. Our sun looks nothing like this. It looks more like this. If you've always thought our sun was a bright yellow ball of fire, you were wrong. For starters, it's not yellow, it's green. Sort of. Scientists determine the temperature of a star by the color spectrum it emits. Each color has its own wavelength, and astronomers measure those wavelengths to tell how hot a star is. Cooler stars appear red, the hottest of the stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it also emits other wavelengths, all these colors mix together, and your eyes see this vibrant mixture as white. That is, if you look at the sun from the International Space Station. From here on Earth, the sun looks yellow because our atmosphere is really good at scattering blue light. And with all that blue wavelength gone, all the other colors combine into yellow. If our star was actually yellow, it would be about 800 degrees Celsius cooler, our solar system's habitable zone would shrink, and Earth would become a frozen, lifeless rock. But that's not the only thing you were wrong about. The sun is hot, but it's not on fire. Burning is a chemical reaction of oxygen with fuel. Like most stars out there, our sun is a ball of gas, mostly made up of hydrogen and helium. It doesn't have much oxygen in it. Instead, it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy, and that's why the sun is so scorching hot. Speaking of setting things on fire, let me tell you about explosions in space. Yeah, these aren't real. A spaceship can't go down in a violent blast because there's no air out there in space. No air means no oxygen, and no oxygen, well, as you already know, means no fire. Sorry, Star Wars fans. It may seem that there are too many stars in the night sky for you to count, but actually, you can. Although scientists at Harvard have already done it for you. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the naked eye. Try to count them all for yourself. Movies make it look like you need to be an extremely skilled pilot to navigate the asteroid belt, but that's not true. The asteroid belt isn't some thick obstacle course of death. It does have trillions of space rocks that range in size from space dust to a quarter the size of the moon. About 100,000 of these asteroids are over 1 kilometer wide, but they're very spread out. The asteroid belt between Mars and Jupiter is 225 million kilometers across. That's 1.5 times the distance between Earth and the Sun. And this spreads the space rocks millions of kilometers apart. It's almost impossible for a spacecraft to collide with one. If you were thrown out of the airlock into the vastness of space, you wouldn't turn into a popsicle right away. That's because, to freeze, there has to be a heat transfer from space to your body. But heat, or cold, doesn't travel very fast in the vacuum of space. Your body would freeze, but it would take hours to happen. And by then, you'd be long dead from something else. And no, you wouldn't explode in space either. You would inflate, though. That's because nitrogen in your bloodstream would gather into bubbles and puff you up to double your size. But that's not what's going to kill you. It's the lack of oxygen. After 15 seconds in space, your brain wouldn't get enough oxygen through your blood, and you'd lose consciousness. After 2 minutes in space, your other organs would start to shut down one by one. Game over. Space seems incredibly cold, but it's not. In reality, space doesn't have a temperature at all. Temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around. That's why the vacuum is temperatureless. Of course, outer space isn't a perfect vacuum. It still has particles and radiation to produce heat. Some areas of space are actually really hot, like the space around stars. But the further away you get from stars, the more spread out the particles are, making those areas of space pretty chilly. Some dense gas clouds can get as cold as minus 263 degrees Celsius. Mercury is the closest planet to the Sun, but surprisingly, it's not the hottest. It is extreme, though. During the day, the surface temperature reaches 430 degrees. And at night, it drops to minus 180. Oof! But the most hellish planet in the solar system is Venus. You see, Mercury doesn't have an atmosphere to retain all that heat from the sun. The Venusian atmosphere, on the other hand, is very thick and it creates a greenhouse effect. It's like global warming on steroids. And it makes Venus a hot hell with a surface temperature of about 475 degrees. Our entire solar system isn't just sitting in one spot in our galaxy. It's hurtling through space at 220 kilometers per second. That's 7 times faster than the speed that Earth revolves around the Sun. Our solar system takes 230 million years to make one orbit around the Milky Way. Yeah, the last time we were in the same location we are now, Earth had one supercontinent and the dinosaurs were just starting to roam around. Planets do not orbit around the Sun. All the things in our solar system are in balance, and even though the Sun is the most massive object in our planetary neighborhood, other planets are participating in this gravitational tug-of-war. Instead of orbiting the Sun, planets and moons orbit around a central point between them and our star. This point is called the barycenter. For Earth, this barycenter is so close to the Sun's core that there's not much of a difference, but for Jupiter, this point is about 55,000 kilometers away from the center of the Sun. So the gas giant and the Sun are orbiting each other. Earth appears round from space, but it's actually an irregularly shaped ellipsoid. It bulges at the equator thanks to the centrifugal force caused by our planet's spin. As a result, Earth is about 43 kilometers wider at the equator than it is at the poles. This makes gravity at the bulge slightly weaker, making it easier to launch spaceships from the equatorial regions than from the poles. In space, no one can hear you scream. That's only true to a point. Sound needs a medium to travel through, and in space, molecules are very far apart, so the sound fades away before it can get very far. All the cosmic catastrophes, supernovas, and colliding black holes go quiet before you can hear them. But some places in space have a lot of particles for sound to travel through. Like the hot gas cloud around the black hole at the center of the Perseus galaxy cluster. It has so much gas that you can actually hear the black hole. This is what it sounds like. You know, that point about astronauts growing 2 inches taller in space has me intrigued. It'd be pretty nice for me to go into space and gain a few inches in height. You know what else would be nice? If you bought a copy of the What If 100. 100 of our most popular hypothetical scenarios explained with science. Bound in beautiful hardcover with the foreword written by friend of the show, theoretical physicist Dr. Michio Kaku. You can pick one up in our merch store at shop.underknown.com. Lots of other stuff there too, like shirts, hats, beanies, coffee mugs. Go on, you know you want something, check it out. Now, you've heard of cryosleep, right? Well, it's the use of super low temperatures to put the body into a state of suspended animation. Now, the hope is that humans will one day be able to use it for space travel, giving us the ability to go to sleep for years at a time until our spaceships could reach a distant planet, like Kepler 22b. 635 light years from where you are sitting, way out there in outer space, lies a planet. The first planet to be discovered within the habitable zone of a sun-like star. Its name is Kepler 22b. When a planet is located within a star's habitable zone, it means there's a chance that liquid water exists on its surface. And where there's water, there's also the possibility of life. Human life. How long would it take to get to Kepler 22b? What would the weather be like over there? And why would you need to get jacked before arriving on this new planet? This is What If, and here's what would happen if you lived on Kepler 22b. Kepler 22b is what scientists call an exoplanet. It's a planet outside our solar system. Spotting an exoplanet like Kepler 22b is often not easy. The bright glare of the stars they orbit tends to keep them hidden from our telescopes. What did scientists come up with to get around it? Looking at the stars themselves to see if they can find anything unusual about them. They spotted Kepler 22b using what's called the transit method. They watched Kepler 22, the star this exoplanet orbits around, and noticed that its brightness changes over time. That was because Kepler 22b was blocking the star's light. With this, scientists were able to learn both the size of 22b and how it orbits. And it looks like this distant space rock could become our next home. Okay, but what do we really know about Kepler 22b? Its mass is 36 times that of Earth, with a radius of 2.5 times larger than ours. 1 year on Kepler 22b is 290 days. It's also located 15% closer to its star than we are to the Sun. If Earth scooched over that close to our star, you'd be fried. Kepler 22b, on the other hand, is lucky to have a sun that is remarkably similar to ours, but also smaller and cooler. This close proximity to its star allows the planet to receive about the same amount of sunlight as we get over here. The temperature on Kepler 22b could be about 15 to 22 degrees Celsius. Similar to Earth's spring weather, and quite habitable if you ask me. But our galaxy can be a cruel place, and not everything is good news. Some models suggest Kepler 22b is rotating on its side, kind of like our very own Uranus. This may sound insignificant, but it adds potentially deadly complications. This would mean that its north and south poles are shrouded in either darkness or sunlight for half a year. And this ain't simply a matter of whether you're a daytime or a nighttime person. A world like Kepler-22b spinning on its side means that temperatures could change from boiling to freezing, which wouldn't be great for human life. I know, what a bummer, but don't despair yet, because known about Kepler-22b. For starters, we still don't really know what gravity is like there. It could be twice as strong as our planet's. If that was the case, a 10-kilogram sack of potatoes would now weigh 20 kilograms. And your body would also factor into the mix. Is your current weight 75 kilograms? Well, good luck suddenly dealing with 150 kilograms of you. And just for safety, settlers such as yourself would need to bulk up. Really bulk up. Only through intense strength training would you increase your chances of being able to walk on Kepler-22b. And once you got jacked on Earth, you'd have to figure out ways to preserve that muscle through all 635 years of lightspeed travel. But humans aren't the only life form that would be affected by a stronger gravity. Plants brought from Earth for oxygen and nutrition might not survive on Kepler-22b when you try growing them there. And if you brought any animals with you, they'd need to step up the evolution process. Higher gravity could lead to creatures developing additional legs to move around. It could also determine the location and size of internal organs. But the mysteries don't end there. Scientists still don't know for sure that Kepler-22b is even a rocky planet. It might be gaseous, similar to Neptune, or it could be entirely covered with water. If you and the other first settlers woke up from your cryosleep and found yourself on a gas planet, yeah, that would be a downer. You wouldn't have a solid surface to even land your ship, not to mention a place to set up camp. In that case, you and your crew would need to figure out how to build a cloud city orbiting the planet. If you landed on an ocean planet, a submarine town would be in order. Discovering Kepler-22b is a rocky planet would be hitting the jackpot then, right? Well, not so fast. Venus is also made of rock, and yet its dense atmosphere, consisting of greenhouse gases, makes it uninhabitable, with scorching temperatures far too hot for liquid water. If this was also the situation with Kepler-22b, our only chance at thriving on this exoplanet would be to employ robots that could build underground shelters. The place where maybe, just maybe, the temperature might be cool enough for you to bear. It just goes to show you that a prime location is no guarantee for human survival. And as exciting as it might seem to find other worlds to inhabit, our own Earth remains the perfect habitat for humanity. Millions of years ago, Earth looked very different. All the continents were fused into one, teeming with life, both beautiful and terrifying. When you think of prehistoric times, you might picture a T-Rex rampaging through the jungle with its razor-sharp teeth. But even before the dinosaurs, there were other giant creatures ruling the Earth. Yeah, welcome to the Permian period. This epic started 300 million years ago. Back then, our planet had one supercontinent, Pangaea, surrounded by a world ocean called Panthalassa. The Permian period began at the end of an ice age when temperatures were much cooler than today. Then, during early Permian days, Earth warmed to a lush environment with a diversity of plants and a rapid evolution of insect and animal life. Only, as you probably know, everything is ever-changing on our blue marble. Over the next 50 million years, Earth kept growing hotter and drier. Eventually, the most deadly event in the history of our planet wiped out nearly everything that ever lived here. Scientists call this event the Great Dying, and it was the most catastrophic mass extinction event the Earth has ever seen. And the Earth has seen 5 of them. But before we get to all this doom and gloom, let me take you on an epic journey back in time. Here in the Permian period, some of the most incredible species that roamed our young planet are about to emerge. If you could time travel nearly 300 million years into the past, you'd land smack dab in the middle of the supercontinent Pangaea. Earth's smaller continents would have just finished colliding with each other to form this enormous landmass, taking up 1/3 of the planet's surface. There was likely less oxygen in the air than there is now, but you still might be able to breathe. Oh, and bring a jacket because it would likely be chilly, with some areas averaging no more than a brisk 4 degrees Celsius. But don't worry, things will soon start heating up. By the end of the early Permian, the Ice Age was on its way out and Pangaea was becoming a lush world. Plants and animals started to thrive. This was a volcanic world. Violent eruptions changed the climate, shaped the landscape, and paved the way for evolution. When giant swamp forests began drying out, plant life had to adapt, and so, 290 million years ago, Earth saw the very first seed-bearing plants called gymnosperms. These plants carried seeds on their cones, and they spread across the supercontinent like wildfire. The ancient evergreen forest of the early Permian was hiding something familiar. Just like today, you could find cicadas and beetles piercing and sucking on the plants, and the cutest of them all? Cockroaches. Only, these weren't the cockroaches you know today. These prehistoric vermin were gigantic, the size of birds. But despite their size, cockroaches never ruled prehistoric land, and that's good news, am I right? No, something much more fascinating was roaming Pangaea. The now extinct ancestor of primitive mammals, Dimetrodon. This animal was as fascinating as it was terrifying. Encountering a Dimetrodon would be quite a sight to behold. This ancient lizard grew to 5 meters long and weighed 225 kilograms. It had a large sail running down its spine. Scientists think this sail helped the reptile regulate its body temperature, soaking up warmth during the daytime and dissipating excess heat during the cooler nights. It would walk toward you like a crocodile and act like a total menace. Dimetrodon was an apex predator of its time. Watch out for a mix of sharp and flat teeth that would slice you open and grind you up. In the Middle Permian period, other mammal-like reptiles took over the planet. Therapsids. They had strong jaws with sharp teeth and a somewhat upright stance thanks to their legs being situated underneath their bodies. Therapsid reptiles varied from the 5-meter-long, likely omnivorous Deuterosaurus to the 5 times smaller, meat-eating Lycanops. You could meet plenty more therapsids if you stuck around for another 20 million years. During the Middle Permian period, Earth kept getting hotter. The average global temperature on Pangaea grew to about 25 degrees Celsius. And volcanoes were spitting greenhouse gases out into the atmosphere. Due to the changing climate, sea levels were shifting, but marine life found ways to thrive. If you were to take a dip in the prehistoric superocean, you'd be swimming alongside ancient sharks and bony primitive fish. Many more complex marine species came and went as the environment kept changing. In the late Permian period, you could have a friendly encounter with another reptile, Lystrosaurus. These looked like a cross between a lizard and a pig, but unlike all the scary prehistoric monsters out there, Lystrosaurus was a herbivore. It was just 1 meter long and had powerful front legs for burrowing. Soon, another cute mammal-like lizard evolved, the cynodont. The cynodont looked like a giant rodent. It was about 1 meter long, had whiskers, and fed on small animals and insects. Now, during this time, something bad was brewing in the air. A large amount of volcanic activity was displacing oxygen from the atmosphere. Scientists think there was as little as 10% oxygen in the air. Compare that to 21% today. You'd have a hard time breathing in that environment. And the temperature kept rising and rising. With an average temperature of about 28 degrees Celsius, this lush prehistoric world was turning into an oven. All good things must come to an end, and sadly, this period came to a particularly brutal one. About 252 million years ago, about 90% of all plant and animal life was wiped out. This tragic moment is called the Great Dying, and it was Earth's most devastating mass extinction event. Scientists still debate what caused this catastrophic extinction. Most theories suggest it was the result of explosive volcanic activity. As huge volcanic eruptions swept the continent, massive amounts of ash were unleashed into the atmosphere. So much ash that it blocked out most, if not all, of the incoming sunlight. And with no sunlight, global temperatures dropped suddenly. Plants couldn't perform their photosynthetic processes and died off. And without plants, the very basis of their food chain, animals soon followed. Things got worse before they got better. Because of all the carbon dioxide emitted during the volcanic eruptions, global temperatures rose again. And not just to where they were, but higher, much higher. And this caused the superocean to lose most of its oxygen. And unable to breathe, a majority of the Permian sea animals perished. Eventually, over 95% of marine species and more than 70% of land animals became extinct. So that's what life was like before the dinosaurs, and then about 250 million years ago, after the Great Dying, well, the dinos started to evolve on Earth. They ruled the planet and stuck around for about 145 million years, until a massive asteroid hit the Earth and caused the next mass extinction event. Sad? Yeah, but I'm not too broken up by the fact that I'm not dodging velociraptors on the way to work every day. Now, let's take a look at how it all went down and what the Earth was like immediately after the dinos died out. 66 million years ago, an asteroid as big as Mount Everest was headed on a deadly collision course with Earth. The impact was so devastating that it wiped out the most gigantic, deadliest reptiles to ever roam our planet. But the dinosaurs didn't just die from one big boom. No, they faced a slow, agonizing end. How did this extinction event cause the largest tsunami Earth has ever seen? And what exactly happened after the big reptiles were gone? Hold on tight, we're taking you on the most epic and deadly trip of your life. This dinosaur-ending asteroid is terrifying. Not only was it about 10 kilometers in diameter, but it also traveled incredibly fast, between 10 and 30 kilometers per second. At this point, it was a blazing fireball. As it hurtled down to Earth, the air in front of it was compressing and heating up to unimaginably hot temperatures. Just before the impact, the asteroid could have been as hot as the surface of the sun. Once it entered our atmosphere, it only took this massive space rock a few seconds to reach Earth's surface and alter the course of life forever. As the asteroid slammed into Earth off the coast of where Mexico is now, it sent huge amounts of debris up into the air. The shocking blast wave killed everything in its way, and from here, it was only getting worse. This powerful blast ejected bits of the Earth's surface into the atmosphere, and minutes later, scorching hot pieces of glass and rock rained back down. Some of the debris reacted with the atmosphere, causing acid rain that would last for years. The land was burning. The fires caused by this devastating impact spread across the continent like literal wildfire, killing more and more life along the way. And then, just when you thought the apocalyptic scenario couldn't get any more intense, well, it did. The impact of the asteroid hitting Earth was so powerful that it sent shockwaves through the planet. And all that energy had to go somewhere. Cue the mega tsunami. A wall of water over 10 meters high raced across the ocean. This wasn't your regular tsunami. It was a staggering 30,000 times more powerful than anything you see today. As this monstrous wave spread across the North Atlantic and South Pacific, coastlines didn't stand a chance. The wave hit with such force that it destroyed and reshaped the continent. If you were there to witness this apocalyptic destruction, well, you wouldn't survive any of it. But some dinosaurs did. Yeah, the ones further away from ground zero weren't immediately obliterated by the impact. They weren't incinerated by the resulting infernos, and they managed to avoid being swept away by the mega tsunami. But still, their fate was sealed. As the dust began to settle, it was the start of a nuclear winter. Even though it wasn't nuclear weapons that caused it, the effect was the same. The massive amount of debris in the air blocked the sunlight for months, maybe even years. Earth suddenly became a cold, dark place, and the dinos weren't ready for it. As temperatures plummeted and fires released enormous amounts of greenhouse gases, the climate changed dramatically. Plants weren't able to perform photosynthesis, and most of them started to die out. This disrupted the food chain and starved many of the animals that survived the impact. And remember the acid rain? It lasted for several years, causing more devastation to the ecosystems. The oceans became too acidic for marine life. Most ocean species didn't have the time to adapt to such a drastic change. These prolonged harsh conditions, together with the initial blast, pushed about 75% of Earth's life to extinction. The good news is that this included the horrifying T-Rex. Yeah, as much as I feel bad for this guy, I'm happy he's not running around today. When the last of the dinosaurs breathed their last breath, Earth became an empty, devastated place, cold and acidic. So when did things get back to normal? Yeah, well, here's the thing. They didn't. Not dinosaur-era normal, anyway. Earth didn't rebuild after that. It reinvented itself. 1,000 years later, the planet was recovering from the post-apocalyptic winter. It was still cold and food was still scarce, but life was ready to make a comeback. In this new wild world, a few furry little critters were sprinting around. Among the first plants to reappear after the impact were ferns. They really hit it off well after the disaster. 100,000 years later, Earth began to get a little more lively. Creatures about the size of raccoons were repopulating the continents. And the oceans were once again teeming with life. Fast forward about 10 million years and Earth had finally restored its biodiversity. Only it wasn't the same Earth as it used to be. Now it was the age of mammals. Yeah, after the dinosaurs checked out, mammals were on fire. Yeah, not literally, of course. Mammals, together with birds and flowering plants, were rocking the planet. Yeah, Earth never got back to its old self. After the last dinosaur died, it took our planet millions of years to bounce back in a new way. But don't get me wrong, this world was still pretty terrifying. It had beasts like Paraceratherium roaming the land and megalodons raining terror in the oceans. Yeah, it's really for the best that most of these creatures aren't around these days.
Titan.
The most majestic of Saturn's many moons. And the most promising for life, too. It's got a beautiful view and liquid lakes on its surface. The only problem is those lakes aren't filled with water. They're filled with liquid methane. Your mission is to take a 5-second dip in one of them. Of course, you'd have to land on Titan first, so buckle up for the most epic adventure of your lifetime. Titan is far. Even at its closest to Earth, this icy moon is still 1.2 billion kilometers away from us. You'd be looking at roughly 7 years of travel alone in a spaceship. You'd need lots of provisions and a super advanced life support system. You know, it would be good if you made it to Titan and didn't freeze or suffocate somewhere in the middle of the solar system. Yeah, that's not going to happen to you. Just sit back and enjoy the ride. Seeing Saturn up close is amazing. Definitely the most spectacular of all the ringed planets in the solar system, but hey, enough sightseeing, it's time to make your way to your destination. Titan is unique in many ways. For one, it's larger than our moon. It's even bigger than Mercury, the smallest planet in our cosmic neighborhood. It's the only moon that has a thick atmosphere. It's also the only one that's covered in liquid lakes, rivers, and seas. And sometimes it rains here too. Descending on Titan would take you about 2.5 hours, and you couldn't just land anywhere. Like I say, Titan is covered in lakes, so unless you wanted to dip your entire spacecraft in liquid methane, you better choose your landing site carefully. Let's try this again. Okay, now that you've properly landed on Titan, let's go explore this icy world. This moon of Saturn might look a lot like Venus, but it's not as hellishly hot. Titan is one of the most hospitable places in the solar system. Yeah, its gravity is only 14% of Earth's, but its thicker atmosphere makes it possible for you to walk there even without a spacesuit. But I wouldn't recommend that. You'd need the spacesuit to keep you warm. Titan is very far away from the sun, so it doesn't receive as much warmth as we do here on Earth. You'd be taking a brisk stroll at a chilling minus 180 degrees Celsius. Well, you wouldn't exactly be strolling. More like bouncing around? Yeah, thanks to Titan's weaker gravity, you'd feel a lot lighter and could jump higher and move with less effort. Now, Titan's atmosphere is mostly nitrogen, very similar to Earth's, but you still couldn't breathe on this moon because, well, that's where the similarity ends. While 95% of the air here is nitrogen, the remaining 5% is methane. You'd need an oxygen tank to survive even 5 seconds on this world. Yeah, it's not just the lakes that have methane in them. There's plenty of methane in Titan's clouds, and sometimes it even rains methane. But this rain isn't anything like you've seen on Earth. It would be more like rain in slow motion, thanks to Titan's lower gravity and thick atmosphere. On Earth, raindrops fall at about 9 meters per second, but on Titan, their speed is only about 1.6 meters per second. That's 6 times slower. It would be pretty cool to walk in the rain here. But hey, you didn't come here for a walk in the rain. You came to take a dip in Titan's lakes.
I wouldn't do that if I were you.
Oh, excuse me? Who's here?
Alright, let's do this. What's up, everybody? I'm Chase. I'm from the year 3050. And for the last, well, things are a bit wobbly where I come from. I've been traveling through space and time a lot. Thing is, I die a lot. Like, a lot. It's kind of like my special power. It all started when I touched this shiny alien cube. Now, I can jump between worlds, dimensions, time, and when I die, I always come back. I'm still trying to figure that one out. I think it has something to do with Einstein? I don't know. It's pretty cool. I jumped on the rings of distant planets, been the guest of honor at an alien feast, and not in a good way. And there was that one time I accidentally started an interstellar war. Cute. But now, I'm here on Titan to stop you from doing, whatever it is you're doing. Because you only live once, unless you're me. So, your mission is to take a swim in one of these methane pools? Let me break it down for you. First off, this ain't no spa day. It's like diving into a freezer. Titan's got this super chilly vibe going on, you know what I mean? At these temperatures, water's harder than concrete. But methane and ethane, they're like, yeah, it's cold, bruv, but like, we can still chill in liquid form. And so they gather up in these cool little pools.
Okay, I knew that too.
Sorry, no interrupting. I'm still just getting to the good part. Now, let's say you're wearing that fancy spacesuit. Good news, you won't freeze instantly into an astronaut popsicle. Bad news, that suit's gonna float. If, for some wild reason, you decided to take the plunge without the suit, well, that's it, my friend. Lights out! You see, the intense cold would freeze you down to your bone. You couldn't move a muscle. And then, the lack of oxygen would get jump. But 5 seconds with the spacesuit on, we'll definitely survive. Probably. Let's test it.
Okay.
Seems like someone's spacesuit can't withstand the cold. Someone needs an upgrade. It's so refreshing out here. I think I'll just stay another 5 seconds just to really enjoy it. Hot.
Chase?
Don't worry. These sparks are supposed to happen. Oh, it's like a stabbing, burning feeling.
It appears that the cold temperature cracked his suit and methane reacted with the oxygen tank inside it. He should have read about this in the mission brief. Well, just leave him here, I guess? Anyway, the mission is a success. The only thing left is to figure out how to get home. So that's Chase, our new what-if explorer. And as you saw, he dies in space. That's kind of why we named his new upcoming show, Chase Dies in Space. Genius, right? Now, you may have noticed that on this show, by the end of every what-if scenario, everybody dies. #shop.underknown.com. Well, since Chase is 100% virtual, he dies, but he always comes back to life for a new episode. That's why we couldn't send me. Too dangerous. You'll see Chase pop up in a few more what-if episodes, and then we'll be giving him his own YouTube channel. It's all quite exciting, but not quite as exciting as our Patreon. Join the What If Explorers Club on Patreon. It's where we give you all the top secret behind the scenes, extended director's cuts, mind-blowing art, epic merch discounts, and our endless love and gratitude. Oh, and we'll even let you pitch ideas for upcoming episodes. Support us on Patreon to get exclusive content and help me send Chase to his death over and over and over again. Okay, this next one was one of my favorites of the year. I learned a lot about the Carboniferous period. It's also called the Coal Age, but it's also famous for something else. Giant insects. Over 300 million years ago, before the age of giant dinosaurs, Earth was covered with giant insects. Imagine a world where dragonflies are the size of crows and millipedes are as long as cars. Welcome to the Carboniferous period. Why were insects so enormous during this time? What did oxygen have to do with it? And why did these insects go extinct? This is What If, and here's what the Earth looked like in the age of giant insects. The Carboniferous period was one of the most transformational periods in the history of Earth. The planet's land masses were beginning to form the supercontinent of Pangaea. Extensive swamps and warm, humid forests dominated the landscape. And giant insects weren't the only huge creatures roaming the planet. There was also a vast array of marine life, like early forms of sharks and a giant amphibian that would reach up to 6 feet long. Now, enough talking. Let's travel back in time, 300 million years ago, and dive into the Carboniferous Age. Now, the first thing you'd probably notice would be the giant insect-like creatures. One of the most iconic was the Meganeura. This insect resembled a modern-day dragonfly, except with a major twist. It had a wingspan of up to 75 centimeters. Yeah, scarier than that though, it was carnivorous, hunting down other insects and small amphibians. Hopefully it doesn't come for you. So that thing is in the sky, but on land, you'll have the Arthropleura. This millipede-like creature could grow up to 2.5 meters long. Luckily, it wouldn't go after you. It preferred munching on decomposing vegetation. Hey, before we talk more about these giant insects, there's another giant issue we need to worry about, and that's our planet's ecosystems and how important it is to help them. Stick around till the end of this video to check out an inspiring project from the folks over at Planet Wild. Another creepy-looking insect was the Pulmonoscorpius. This was a giant scorpion that mostly roamed the swampier areas of Earth. They could grow 70 centimeters long. There were also giant cockroaches that grew to 10 centimeters and mayflies with 45-centimeter wingspans. So it's safe to say that you'd have a lot to watch out for when you're wandering around in this period, but The question is, how did these insects get so big anyway? Well, you may have noticed as you've been hanging around in the Carboniferous age, you feel a lot more energetic and alert. Maybe you've had an easier time running around. This has to do with the oxygen levels in your current world. Research has estimated that the atmospheric oxygen levels were as high as 35% during this period. Compare that to the 21% we breathe today. Oxygen was one of the key factors in the gigantism found in insects at the time. But why would this make them so giant? Insects breathe differently from other creatures. Insects don't have a circulatory system to transport oxygen. Instead, it gets delivered directly to their tissues through a network of tiny tubes called the trachea. And the more oxygen in the atmosphere, the bigger these insects are. But there might be more reasons why the insects grew to this size. Another theory suggests that the insects were forced to grow so large due to oxygen toxicity. Yeah, as amazing as oxygen is, you can have too much of a good thing. Too much oxygen in your body can create what's known as free radicals. These are unstable molecules that can damage your cells and even damage your DNA. In the case of our insects, they were forced to grow this big. Otherwise, they'd suffer oxygen toxicity. Growing larger would slow down the rate of oxygen absorption, making it harder to suffer from too much oxygen. And the same could happen to you. The longer you hang out in this period, the higher oxygen levels will cause you to experience nausea, respiratory issues, and even some effects on your nervous system. Now, insects were arguably the stars of this age, but they weren't the only things to experience massive change during the Carboniferous period. This time was known as the Coal Age. That's because of the extensive coal beds that formed after ancient forests decayed. These coal beds are one of our main sources of energy. We're still using them today. And a lot of the fruits and veggies you find in the grocery store may be descendants of plants from over 300 million years ago. The Carboniferous period saw the evolution of the first seed-bearing plants, creating more diverse ecosystems than we'd ever seen before. Wait, what's that over there? Kinda looks like a dinosaur. Oh, hey little guy. Turns out this wasn't a dino, just one of the first reptiles to ever appear. But if you stick around a couple of million more years, we'll enter the Mesozoic era, which was known as the Age of Dinosaurs. Speaking of change, the atmosphere was another part of Earth that evolved during this period. Earth had a lush, greenhouse-like climate when you first arrived, warm and humid temperatures to support the swampy forests we've been mucking about. But as the period progressed over millions of years, the climate transitioned to what's known as an icehouse Earth state. The temperature would get significantly lower and ice sheets would begin to form, mainly in the southern hemisphere. But why did this happen? Well, as we've been exploring this crazy period, Earth's land masses have been slowly coming together to form a supercontinent known as Pangaea. And when land masses this big start to move, it can seriously affect ocean currents, wind patterns, and global climate. Now, the rainforests have collapsed, which has led to a decline in the fauna and vegetation that were previously booming. And with the rainforests in decline, well, that means oxygen levels are being reduced. Before you know it, our massive insects start dying and going extinct. Without the higher levels of oxygen available to support their size, well, these giant insects can't survive. The lower oxygen levels and a drier climate have created a habitat better suited for smaller insects. Also happening at this point, early reptiles are starting to take over, making the landscape way more difficult for the insects. Researchers have detected strange radio signals coming from deep space. These mysterious radio waves might just be bursts of cosmic energy from a distant neutron star. Or it could be that scientists have discovered a highly advanced civilization 90 light-years away from Earth. So, what kind of civilization would have the ability to send strong signals like this? Well, scientists classify civilizations on something called the Kardashev scale. It's a scale that measures a civilization's technological ability to harness energy. While it's a hypothetical scale that could eventually have 5 or more levels, most scientists only refer to the first few. But don't be underwhelmed. We're the only civilization we know of, and technically, we're still stuck on Type 0. At this stage, we've managed to harness some, but not all of our planet's potential energy. We consume about 18 trillion watts of power every year, and if we wanted to bump ourselves up to a Type 1 civilization, we'd need to consume over 500 times that every second. To do this, we'd need to harness, store, and utilize all of the energy available to us. That includes all raw materials and every bit of sunlight that reaches Earth. We'd also have to tame volcanoes, earthquakes, and other natural forces. At the rate at which we're developing now, it's possible that we could be a Type 1 civilization within the next 200 years. But whatever civilization scientists may have discovered in the far reaches of space could already be a Type 2 civilization, or higher. Once our civilization has all of the energy available on our home planet under control and we graduate to a Type 1 on the Kardashev scale, then we need to take the next step. Time to crank up our energy consumption to 10 billion times what it was before. To do this, we'd need to harness not just all the solar energy that reaches Earth, we'd need all of the energy our star generates, period. If there is a Type 2 civilization out there, they're probably using an incredible system to do this: a Dyson sphere. They'd build this megastructure around their star to collect all the energy it radiates out in every direction. They could even assemble other Dyson spheres around the first Dyson sphere to guarantee that little to no energy escapes. But there's nothing simple about this technology, and that's why only advanced civilizations could construct something like it. For one, a Dyson sphere must be larger than the star itself. And if these megastructures are bigger than stars, well, they should be easy to spot, right? Well, this could be tricky. Once a civilization is finished building the Dyson sphere, the megastructure blocks nearly all of the visible light from its star. A civilization this advanced could make its own solar system invisible. Lucky for us, visible light isn't the only way to detect a star. Even with a Dyson sphere blocking its light, a star would still radiate heat, and we could detect the star by the infrared light it gives off. But that wouldn't be the only way we might discover a civilization this advanced. Remember that strange radio signal? It originated about 90 light-years away from Earth, coming from the star HD 164595. Was this powerful radio signal created by an alien race and intentionally pointed toward Earth? A civilization able to pull this off would need to be far more advanced than our own. This Type 2 civilization would be able to utilize the raw materials on every planet in its star system, and maybe even beyond. They may have built fusion reactors that orbit their planet, fueled with gas from other worlds with hydrogen-rich atmospheres. And they might be mining precious metals from rocky planets, just like Earth. They could terraform other planets into livable worlds for their populations, and they wouldn't live in fear of civilization-ending natural disasters like asteroid impacts, ice ages, or global warming because they'd have technical solutions for these too. This alien civilization would be at the stage on the Kardashev scale where they'd be able to master interstellar travel. But if that's true, there should be no reason for them not to pop by for a visit, right? Well, not so fast. With all the advanced technology they might have at their disposal, these aliens could be waiting for us to catch up. That way, when our civilizations meet, we would do so as equal partners. Who knows? They could be so advanced that they're no longer a fully biological race. They could be more like cyborgs with a mix of robotic and organic material. This would make them capable of incredible things that humans could only dream of. But they wouldn't stop there. An advanced world like this would want to go farther up the Kardashev scale, and as they became a Type 3 civilization, they'd rely on something other than the power of their own star system. They would harness the power of several stars in their galaxy. With this much power, a civilization would have no problem meeting its ever-growing energy needs. They'd just hook up another star when they needed more power. If we ever advanced to this level, we'd have 100 billion stars available to harness in the Milky Way galaxy alone. A civilization like this would no doubt be the rulers of their galaxy, and they'd have the power to move entire star systems, merging them to harvest the energy they need more efficiently. So if one of these civilizations existed, well, you could detect them by observing the sudden disappearance of many stars in a faraway galaxy. This could be a sign that Dyson spheres have been constructed around not just one, but several stars. A Type 3 civilization could already be out there. After all, scientists have announced that they've found 2 galaxies with a highly unusual amount of infrared light. This is something we usually observe in galaxies where new stars are being born, but some unusual and sudden spikes in infrared light could mean that we've found the first signs that civilizations many times more advanced than us exist. Maybe they're about to make contact. Or maybe they already have. If this is how you picture walking on Uranus, you're wrong. Let's start this again. Are you ready to take a trip to the outer regions of the solar system? To explore the weirdest planet in our cosmic neighborhood? To venture down into a place that's never been studied up close by any spacecraft? Buckle up for an icy, violent, and stinky adventure because your mission is to spend 5 seconds on Uranus and come back. If you can. Traveling to Uranus would be a long, strange journey. First, you'd have to spend 10 long years in a spaceship, speeding toward the outskirts of the solar system. If you're lucky, you might even pass Jupiter and Saturn on the way. Just make sure you pack enough food and fuel. Well, there are some things you should know about this world. Uranus isn't a rocky planet like Earth. It's an ice giant like Neptune, and it's the only planet in the solar system that spins on its side. It spins fast, too. One day on Uranus is just 17 Earth hours. Of course, you wouldn't last that long on it. Not a chance. Once you arrived at your destination, you'd still have some work to do to get close to this giant blue planet. You might have to dodge Uranian rings. Yeah, Uranus has rings. 13 of them. They aren't big and majestic like the gorgeous rings of Saturn. The outer rings are bright and easy to spot, but the inner rings are narrow and dark. You'd have to navigate this part of the trip with the utmost care. As you made your way through the dusty rings of Uranus, you'd see its glorious blue atmosphere up close for the first time in human history. Take a moment to enjoy the...
Ah, Uranus. What an oddballs planet. You know, I flew by it a month ago. That was fun. You wanna know why nobody, and I mean nobody, has ever tried to land anything on the surface of this bootyful planet? Because Uranus has no surface. It's just a swirling ball of toxic gas compressed around a small, icy core. Oh, and wait till I tell you why those gases on Uranus are toxic. Yeah. Gross.
Yeah, okay, thanks for your input, Chase. It's true, Uranus might have a calming blue color, but it's cold and toxic. Not the kind of blue planet you want to visit.
That's okay. I think you should sit this one out. Here I go! Woohoo! Ah, it's brisk here. Oh, Rico, what's the temperature?
Minus 224 degrees Celsius.
Oh, that's cold. That explains why I can't feel my fingers, or my toes, or the rest of my body. Okay, well, at least those 5 seconds are done. Okay, Rico, it's time to go home. Let's bounce.
Impossible. If my calculations are correct, you will reach the icy core in 54.4 minutes.
So? What? That wasn't the plan. And what's 0.4 of a minute? Use seconds, you dumb bot!
I suggest you take this opportunity to study the planet up close and report back.
Well, I suggest you take this opportunity and stuff it up your charging port!
I don't have a charging port.
No one cares, Rico! No one cares! Honestly, this sucks. Uranus smells like
Yeah, the reason Uranus smells so bad is that the clouds in its upper atmosphere are partially made up of hydrogen sulfide. Not only does this make the planet stink, but it's also pretty toxic. Whatever you do, do not inhale it. If you did, it'd make you faint and die instantly.
What? It would have been real nice to know this before I jumped.
Yeah, well, after falling through the stinky clouds at the top atmosphere, you'd find yourself in the mix of 82% hydrogen, 15% helium, and a bit of methane. Methane gas is what gives Uranus that bluish-green haze because it absorbs light at the red end of the spectrum.
Huh, these clouds are getting a little weird. Kind of floaty.
Yeah, the atmosphere on Uranus is very dense. After passing through its top layer, you'd stop falling and start swimming in it instead. As you were paddling deeper, you'd start getting pelted by frozen gas crystals. But at least the temperature would be rising.
I don't know about that. I don't feel warm at all. Rico, give me the stats.
The temperature around you has indeed gone up to minus 208 degrees Celsius. My calculations show you can expect minus 153 degrees Celsius in the lower atmosphere.
Cool. Great. Ow! Ow, what is that?
That? Well, that's diamond rain. Yeah, on Uranus, it rains diamonds. That's because the Uranian atmosphere is rich in methane, a single carbon compound. Under extreme pressure, the methane molecules break apart and crystallize into diamonds. But the worst part is the wind. You'd be dealing with winds gusting at speeds of up to 900 kilometers per hour. That's 3.5 times stronger than a Category 5 hurricane here on Earth.
Rico, it's getting tight in here. Oh, I can hardly breathe. And when I do breathe, it smells like ass.
Of course. The pressure is 100 times greater than the atmospheric pressure at Earth's sea level. You are approaching the mantle.
The good news is you wouldn't splatter on anything because there's not much in the way of solids on Uranus. The Uranian mantle is made of water, ammonia, and methane ice. It would be pitch black in here, and thanks to the extreme gravity, you wouldn't be able to move a muscle. And it would still be incredibly cold. What you should be worried about is the immense pressure that would be rapidly increasing the closer you got to the planet's center. it would squish you before you ever got to the core.
Being crushed by Uranus. I always thought it would be way nicer.
Well, in this extreme pressure environment, your carbon-based body could turn into diamonds and drop down into the core. What a spectacular way to finish this one-way trip to the center of Uranus. Chase? Oh, right. Okay, that's it for today's show. Thanks for bearing with us and beholding the beautiful, bounding, and buoyant best of What If for 2023. Hope you enjoyed it. Hope you learned a lot. We'll be back soon with another What If. Hey everyone, welcome to the What If live stream. It's great to have you all here. Mom, I see you joined us today. Look, I got about an hour's worth of the best what if scenarios of the year to show you, and I'm eager to get started, but I just want to let you know what's in store. Now, this was a great year for What If. We covered lots of new ground, did some longer form videos with me called What If Originals. We're upping our game with visual effects in our videos. We launched our Patreon. We introduced Chase, a new virtual